Alright guys, today's goal, the learner will understand series. So you're going to learn about summation notation, sums of arithmetic and geometric sequences, infinite series, and the convergences of geometric series. And why? Infinite series are at the heart of integral calculus. So let's take a look at an example. In summation notation, the sum of the terms of the sequence a sub 1, a sub 2, a sub n is denoted by the sum, where k is 1 to n, of a sub k, which is read the sum of a sub k from k equals 1 to n. The variable k is called the index of summation. So the sum of an infinite arithmetic sequence, or of a finite arithmetic sequence. Let a sub 1, a sub 2, a sub n be a finite arithmetic sequence with common difference d. The sum of the terms of the sequence is right here or right here, doesn't matter. The two most common I use are this and this. So they're both first term plus the last term, and then you have n divided by 2, or first term plus the last term divided by 2 times n. So they're the same thing. Okay? Or if you wanted to, you could do, and this might even be even better. All three of these are very easily used. Okay? Let's take a look at an example. A corner section of a stadium has 6 seats along the front row. Each successive row has 3 more seats than the row preceding it. If the top row has 24 seats, how many seats are in the entire section? Okay, well, we have to figure out how many rows are there. So use the explicit rule. 24 equals 6 plus n minus 1 times 3. 18 equals 3n minus 3. N equals 7 rows. So now we can just use the sum. They use k equals 1 to 7. So it's 7 times 6 plus 24 divided by 2 equals 105 seats. Okay? So let's look for geometric now. Sum of a finite geometric sequence. Okay. So let a sub 1, a sub 2, a sub n be a finite geometric sequence with common ratio r. Then the sum of the terms of the sequence is first term times 1 minus r to the n divided by 1 minus r. Okay? Now, notice it says finite. Unlike arithmetic, you can actually have an infinite series in the expression of these. It can exist. So the geometric series sum of k equals 1 to infinity, a times r to the k minus 1 converges if and only if the absolute value of r is less than 1. So if you had a geometric equation like this, see how r is 2 or even negative 2, but the absolute value is 2, so it would not exist. You do this. The absolute value of negative 1/3 is 1/3, which is less than 1. So you can find the sum, the infinite sum of that one. So let's look at some examples of this. Determine whether the series converges. If it converges, give the sum. Okay, so does it converge? Well, the absolute value of 0.25 is 0.25, which is less than 1. So yes, it converges. So find the sum. So the sum equals the first term. So plug 1 in to k. So 2 times 0.25 to the 1 minus 1. So the first term is 2. 1 minus r. Oh, no. I'm thinking the big one, sorry. It's just the first term divided by 1 minus r, because we're doing infinite here. So 2 divided by 0.75. The sum is 8/3. Okay? So there you go. See you guys tomorrow.